Okie dokie, let's go. Accidentally uploaded a video to the wrong channel, but it is what it is. Functions that were instantiated from templates that we don't have to do, it's implicit, it happens automatically, the compiler does it. They're inline. Yeah, because we have different files, those different files have their own copy of the template because the compiler needs a definition of the template. It then instantiates the specific definition that matches the function calls or the class instantiations, class object instantiations. And then boom, deduplicates the extra definitions. So that there's only one for each. Functions, yeah. Gotcha. Meaning it doesn't matter what type of function is instantiated, they're all implicit. Therefore, cool. But the ones outside should be defined below and with their own little template. All right, let's see. Write a class template named Triad with 3 private data members. Gotcha. Constructor, access functions, and a print. That's it. Easy enough. Okay. Let's do it. And now we'll do, excuse me, our header file. Okay, of course, I put in an extra letter. Hold. Alright, now we're good. Not trying to have to edit this fucking video. Alright. What else? That's it? Okay. Messed up on the member names. Oh, the print defined outside. Okay, so we need the getters and then the print defined elsewhere. Okay. It's crashing again. I can't, bro. I cannot. What is, why? What is taking up the GPU? Bro, what the fuck? Okay. Guess the quality is good or something. Gotcha, because they still need to be declared here. Fucking duh. Cool. And I can implement this in a sec. What? Excuse me. Okay. Why is it cool there? What X is it thinking? I don't know. Let's do this one by one, actually. This is probably the best way. Set Y. We have a constant U, because Y is a type of U, and this is called Y. And this is Y. And this is also Y. Set Z. This is V. This is Z. This is Z, Z. Pass it the values that it accepts. Cool. And these could these be made explicit? Oh shit, to avoid implicits, that's cool. What were the multiple issues it was having? Oh, okay. It gets a whole bunch of issues when it yeah, it just wasn't okay. I don't know why it's generating both of these. What is that? Oh. Oh. I'm not sure why it's cool with one argument or two. So it was saying there's a version that expects one. Oh, hold on. Triad. Oh, I guess it's saying it could be both ways. Oh, it's expecting one argument, and the argument is a triad, which it gets converted. Okay, gotcha. Alright, that makes sense. Are you sure, buddy? Oh, that's what you're saying. Instead of get that, you're saying... What else? That's it? So you have one with 1, 2, 3. Print. Well, my print, I mean, if you don't want that, because you're already doing that, so you're doing print and then an inline. I'd rather just do the inline there, but okay. So you're doing 1, 2, 3, and then you're ending the line, and then doing the first one, 1, and then you're saying namespace, and you're passing it a standard string. Yeah. Yep. That works. Cool. You happy? I like doing CTAT. I don't like doing in. I mean, you know what 1 and 1 and 1 are going to be, or what your 3 integers are going to be. They're going to be integers. Well, no shit, buddy. You're saying from... Well, yeah, because if you remove const here and const here, you're cooked. Compiles here, but doesn't compile in main. Why is it? Because we have a const object that we've created, and we're using a non-const function on a const class object. No, sir, can't do that. Noper. Yup, easy peasy. Alright, how long has it been? 13. I started at 55, so we'll go till 8:25. Hold on, let me get some out of my teeth real quick. Spaghetti's good, it's just that the pepper gets inside my teeth. I have tiny little divots in my teeth from when I used to grind. I have a mouth guard now, but the fucking divots are just big enough to hold like a piece of pepper. It's very annoying. Alright. Toothpicks though from work, so easy peasy. 7.1, global variables. Yep, start and end. Yuppo. True, but global should still be in scope technically, always. It's just that you don't have it defined somewhere. Maybe you don't have a declaration to it, so maybe it isn't able to be used. Would you say that's out of scope? I guess so, right? Let's say a function in one file and a function in another. The variables that they each define inside each other, are they accessible to each other? No, they have no linkage. Can't do it. They're out of scope, so yeah, I guess so. That makes sense. It's out of scope. Sure, I'll say that. All right. Yeah, so here we have a static guy, 0. We return the incremented one, says 1, 2, 3. Cool. Okay. I mean, we already saw it a second ago. It said the static variables are those that are unrelated to other member variables within the class. Thus, they're not to be initialized during, I guess you could say either, but during the class's initialization. They're only default. Oh my god, there was a buzzer sound in a song. They're only initialized, I guess, by default. Or, well, yeah, but they have their own default value, which means we don't have to worry about any classes having well, I mean, I guess maybe they're not unchangeable. We don't have to worry about initializing the class changing the value. So we can use them as default values when initialized in the class because the values are known. Okay. Before we go into the static keyword, let's check this out. All right, so in main, we have some class objects, looks like, or an alias, but class object probably. And then we're setting the first value, so we have an aggregate here, or at least it's a public member data member. And then we're printing it and then printing the next. Okay. Okay, we have a struct called something and it has an int value 1. Okie doke. So we have something first, it gets 1, something second, gets 2. First that value is now 2, and we print first value to get 2, print second value probably to get 1. Because first is the one that got set to 2. Cool. Create an object. Each object gets its own copy of all, so static will be shared among them, meaning that if you change it in one, it changes for all? Maybe? So like, if that's the case, you could have like Call of Duty zombies, right? You could have different in the recent retarded zombies. You got all these different types of zombies, and they all have their own different type of health. There's like little crawlers and these guys and those and all this different stuff. The fucking big metal guys, all that stuff. But each round, the base health that they all start with, or the health bonus that they all get, the static variable in their class, gets changed. So all of them rely on the same number as a bonus to their health. So even though one zombie gets 100 health, one gets 200 health, one gets 400 health, because they were just initialized with different values, they all get the same round bonus, or maybe bonus percent, something like that. I could see that. If they all share something, just like they share the same class, maybe they share a same class value, that where it gets updated for one, it's updated for all. Or maybe just none of them can touch it. Two somethings and each one, yep, each one has its own value, so we have a first and a second value. We can make them static. Oh shit, static member variables are shared by all objects. Oh fuck. What about speed? I guess the pitch does change. Too fast. Like, I mean, can we make an example like this? Hmm. Excuse me. Does it need to be const? Oh. But not there, huh? Dang, but then you can't change it. Alright, I'm curious. Gotcha. Surprised we don't even, I guess we don't have to say extern. Okay. So in this case, we would say oh, wow, you don't actually even specify static here. Interesting. Oh, and we can initialize here. Okay. Okay, so just health is still the same. But if we create another one now, oh wait, let's say it's 0. Oh, oops, I literally didn't even change it. That's why I hate copy pasting. No, it's 10, cool. Okay, so we could have zombies, and then... Oh, wait. Hmm. There could be some world state stuff. Let me update the round, and then... Okay. We say is just health is 5, and then we kill the zombies, another round has passed, and then the zombies spawn again, and they always get spawned with 5 as the health, and maybe that's always it. The default health actually just is 5, and they always get spawned with... Or we could say the round health bonus starts at 5, actually. And so we can start them off with the round health bonus. That's cool. And then we actually... I think, can't we get by technically without a constructor? This time we're not passing it extra health. Same result. It's just that the health starts with 5. Something like that. Cool. Alright, the idea works. And the point is that we can change it, and new objects will adjust. Well, everything gets it, but it's not going to overwrite their initializations. It's just going to mean it so that new objects get different values. I'm picturing a company with an old login system, and they have this way of logging in this class. And the way of logging in depends on this static variable. Well, at some point they update the static variable, which updates for everybody, but only the new people have their constructor called, which forces them to actually use the new login method. The people who already exist, the oldies, well, their constructor hasn't been called, so thus the functionality that makes them have to relog in or whatever hasn't been called again. They don't have to do anything. They don't have to reset the passwords or anything. It's only the new people who have to do this new system. So could be the case that you have some sort of check or something where when that, oh yeah, I guess that's what you would do. In the function that updates the static somehow updates each of the objects or something like that, maybe. Oh, even though it's Japanese, I'm still getting a little bit of that time slow thing. Cool. Yep. Yes, exactly. That's why I'm not sure what the best practice is here. Is it to pick an object and change the static through that object? Or is it to just create a temporary to do it? Because it seems like you can't access it through just something. Well, actually, no, because it was private, so you can't, I don't think. Well, you could. Oh, I guess that's when you would define that outside, huh? Fuck, can I bring zombie back? I guess not. Damn. I'm thinking you have a class, and then you have a function defined on the outside that you can resolve scope to get. Like... I mean, because we did that in order to get the class inside. Can we do it to get function? If it's a public function? Excuse me. Fuck, it still must be called on an object. Oh, but it could be... Hmm. Well, I guess it didn't like that syntax. Just took a while to update, I guess. Uh-oh, hold. Guess it can't be const. We can change it for the whole thing. Okay, that's where... Okay, so we can get and set them without having to have an actual object if we make the function static. Interesting. Yep. And static, even in this case, still means that it was created at the start of the program. Oh, that's cool. That's cool. You could have day, and then the days within the day that's current day, all that kind of stuff. Ooh, so it's like a safe version of a global variable that exists within the class that it's used in, instead of just having a namespace that gets used everywhere. This seems like the safest way of using a global variable, basically. Make it a static member variable. Yep. Comes the section below. Yeah, we can get and set the health that all the zombies are getting. We could get and oh yeah, exactly. We can get and set the spell bonus damage or the current spell level, like in Mage Arena. If you capture flags, the class of the wizard gets updated so that everybody's spell damage goes up. So even though they're all individual objects, their damage depends on the spell. And you could say that, whenever you update that, well, whenever the static has been changed, all the people's damage. Oh, that's actually what you do. You just make it so that the stuff they do is dependent upon that value, so that you don't have to call something specifically to update their damage. Instead, their damage is just done in that function. So, like, for example, wizard casts fireball, does 35 damage, or let's just say 35 damage. Well, it's actually 35 plus level bonus. And let's say each level is 10 damage. So level 0, 35 damage. Level 1, every time they do damage, oh, now it's 45. Oh, 55, 65, 75. You don't have to do something where you apply that to their actual damage. You just, in the function, use both values. That way, as the static value changes, the real damage they do end up changing. That is nice. I like static member variables a lot. These are beautiful. Trying to think if this is useful for the game. Liar's bar. Like the round card. I mean, if we had one class with all the players and everything, then sure. But we could have a class that's called the game. And the game has a number of players that are alive, and each player, something like that. That could be the structure, actually. We have a table, and it has a number of people, and they each have their own information, their own objects. But in hell, we could even define the class within the class, actually, but maybe not in this case. We just define them separately and put those in this class. We put the people inside the table class, and then the class has, well, let's see. I guess it's not needed there because there's only one table. Not really needed right there, but I could see this being helpful. I mean, if class was a player, you could set it so that all players, well, because that would be all players, I guess. I guess you could have multiple static. Well, you could have multiple statics in the player, and the damage would use the right static depending on the player's name. So if the name was this, or if the player's team was this, use that static. Use the blue team static. If the static was this, use that team static. Oh, that makes sense. That actually works in the Major Arena case too, because it's not that everybody in the world gets a damage bonus to the spell. It's that your team does. Well, how do you change the static without changing all objects? Well, you do change all objects. You just make it so that each object uses the values how it needs to, depending on the team. So if the team is blue, applies the blue bonus damage. If it's red, applies the red bonus damage. Nice. And it's public here. Yep. Makes sense. Why would I want to access it through an object? I wouldn't. I mean, unless that character was the one who was changing it somehow. I mean, I could see that, or like the person who, I don't know, if it's League of Legends or some bullshit where the person who does something gets most of the money and the rest of the people get a little bit less or a little less of the buff. You could put the function that updates the static variable, the static member variable, also takes this pointer and it updates that character and the static. So that character, that object gets extra 10 to his damage, and everybody else gets, but everybody gets plus 3 to the damage. So he actually gets plus 13, but everybody else gets 3. Cool. Fuck. Out of time. Time for self-test. Okay. So the music is just really, really, really nice. Oh, it's thinking rare. Okay. It's good enough. It's not everything, but yeah. One 1.7 or 1.8 is pretty good. Let's do 1.8. Fuck, and we were just about to get to Y2. Or oh yeah, because there's no pointer to this here. I mean, I guess we could say, oh, couldn't we do that? Could I just do that? I don't know. So we could do either way. Okay, 94. Cool. And if we wanted, we could do. And we could do this separately, but in this case, it's fine. I think it's funny too. And I could do that, but I'd rather do this. Cool. What else? Excuse me, I think that's it. Thought I heard some noise. Use a function to swap the values of two integers with pointers. Well, I mean, I think, can I use standard swap like that? I'm curious. Yeah, I can. Alright, what if we did? What if we dereference the address of X and dereference the address of Y? Holy. We could say sure, I'll do it twice. Well, nah, fuck it. Kinda lazy. Oh, I can. You can do it two ways actually. So I don't have to have a function that takes the address. Oh wait, hold though. Fuck. That doesn't help at all though, because I'm swapping and I'm passing. Well, it's actually the same. It's the same cost, so doing pointers like that doesn't matter. But I could just have a function that takes two pointers, who pass it the address, and then bop, have an integer to hold one of the values, take that, or initialize that with one of the values, assign the x's value to y, and then assign x the value from the temporary value, which is initially y's. Could pass. How does that even work? If I pass the dereferenced address, I pass the dereference. Hold on. It's expecting two values. Or it's expecting two objects. And I'm passing it two objects. I'm passing it by. What do we even say? How does that even work? I passed it the dereferenced address? Is that just like passing a reference? Right? I've never done that before. That felt crazy. Could create a function called swap to ints. Int pointer x, int pointer y, which assigns y's, well, the dereferenced, or well, y's, one's dereference y's value to a temp, well, which initializes a temp int with dereferenced y's value, then assigns x's value to y, well, dereferenced x's value to dereferenced y, then the temp int holding y's value to dereferenced x, changing the values where they are memory by via pointers. Also could use algorithms standard swap. By passing it dereferenced addresses. That is crazy. I've never seen a dereferenced address pass. What do you even call that? Just an object? Yeah, I guess so. But yeah, because it's expecting a reference, I guess, or it's expecting an object. How does that even fucking work? Or yeah, I guess it already is expecting it's expecting a reference, right? Yeah, let's just find that. No, damn it! Oh, it worked. Swap. Hold, hold, hold. Left and right. Pointer to left and pointer to right. Cause afford it one. Yeah, I'll take it. It seems like they're pointers. So, well, if it's a pointer, then well, I mean, '88. Oh wait, do we have? It's going. Okay, good. Pointer to const. I need the music. Let's go back to slow mo. That's a good feeling. It's not as bad as English. When it's English, it's bad. That's a good feeling though. Alright, pointer to const. Pointer to const is a pointer to a constant object. Or, well, to a pointer that treats the object it's pointing to as const, regardless of whether it's const or not. A const pointer is a pointer that cannot be changed or pointed to something else, but isn't treating the object it's pointing to as const, and thus, well, unless it's a const pointer to const. A null pointer is a pointer holding the value null pointer, which makes a pointer point to nothing, and dereferencing it yields undefined behavior. Passing by value means creating a temporary, well, hold on, it means copying the value from one location in memory to another. So when copying int x's value to an int parameter, for copying x's value to the parameter, which isn't expensive for ints, but could for class types like standard string. Passing by reference means passing an alias to an object. Deeper, basically passing a const pointer. To a function, which lets the function change the value where it exists instead of first copying it. This lets functions change values where they are without us needing to copy the return value back to the object, nor copy it to the function. From 2 to 0 copies. 85. Non-type template parameter is a template parameter that isn't a type, like an int, well, like isn't a placeholder type. They require const expression arguments allow us to use const expression values to const expression function templates do code duplication, generating instances, well, individual instances with their type templates overwritten, well, placed by the types of arguments and function calls. Thus, we don't need to make 4 versions of print tx to handle long int float standard string. Yeah. We can just go on template to handle that and more, letting the compiler generate the necessary instantiations. Okay. Well, I didn't mean to say that they were secure or private. I just meant that we could make them like that so we don't fuck with them outside. Because we would probably, I would guess that we would want them to be private usually. Just like we would want global variables to maybe be as untouchable as possible. Usable everywhere. but with safeguards. Not all static members. If they're const expression or inline, then they don't need to be out of class and initialized. Okay. Technically, it is initialization before any object is created and destroyed after the program ends. Meaning that program starts, static objects are created, and then other objects are created. The program runs, and more that happens, and then the program destroys the static objects after the locals, and then the program ends. Okay. Okay. Static inline, gotcha. Which makes sense. I mean, wouldn't we want to do that here? Uh-oh, can't be const expression. Bum, bum, bum. It's fine. Cool. Ooh, they're called in reverse order of construction for non-static data members. Oh, meaning so they are construct this guy, this guy, this guy, and then it destroys this guy. Or what? What are you talking about? In reverse order of construction? Bro, what are you talking about? I don't know what that means yet. In the reverse order of construction. The rule of three. Oh yeah, if it needs something, then it probably... Yeah, if it needs a constructor, a destructor, and static or something, it probably needs all three. Or if it needs these three, it probably needs all five. Something like that. Oh, move semantics and other stuff? Okay. Is it memorable? Yeah. Oh yeah, duh, I forgot, because if it's local, it's going to be destroyed at the end. Yeah, I should have specified that too, okay. Yeah, because this depends on the function. It's a pointer to it's a const pointer, or it's a pointer to its a const self, or it's just a pointer to self, depending on if it's a const function or a non-const function. Oh yeah, true. And we can return this. That way we can... So in a member function, we can return the dereference this. That way we can do dots, whatever. So we can do add something, and then it returns this, and then boom. Okay. A non-static member function. This is always the type that... Oh, I'm not sure why we're talking non-static. I don't know static yet. Maybe static has to be const? I don't think so, though. Oh, true, because it's not initialization. Yeah, makes sense. Yeah, makes sense. Yeah, because otherwise the copy constructor isn't doing anything, and then it's just a function. So, I mean, sure, it's doing it, when you create, it's called at the same time, but it's happening later technically. Yeah, I totally know about deep copying, buddy. Yeah, makes sense. Okay. Okay, just don't do assignment. All right, good to know. And plus to kitchen air wings too, maybe, but. Fuck! I meant, well, no, I said here, I said scoped. I meant scoped in that they don't implicitly convert. It's just that the question was asking about unscoped, and I was comparing them to scoped because I think it's important. Yeah, I don't really care about that. Yeah, it's not missed or misconstrued. I just didn't explicitly show the syntax, dumbass. Yeah, it's type safe because it's explicitly a pointer value. It's not implicitly convertible to integers and whatnot. Oh, and true. We do const references. Well, I mean, we can do it either way. It's just that we do this by safely without copying. Makes sense. Or well, without copying. That's what I meant. Without modifying. Okay, sounds good to me, buddy. Done. All right, more tomorrow.